Welcome to Module 2, Basic Switch and End Device Configuration. This is where the course goes hands-on. Everything from here builds on packet tracer or real hardware. Set expectations. Today is about getting comfortable typing commands, not memorizing every option yet. One objective: implement initial settings including passwords, IP addressing, and default gateway on a switch and end devices. Preview the topic list on screen so students know what is coming. iOS access, navigation, command structure, saving configs, ports and addresses, and connectivity verification. Every device needs an OS. Draw the hardware to kernel to shell to user chain on the board. Kernel talks to hardware, shell is what the user actually interacts with, either through CLI or GUI. This vocabulary, shell versus kernel, comes back on the quiz, so slow down here. Contrast GUI and CLI directly. GUIs are friendlier, but can crash or miss features. CLI is lighter and more stable, which is why network devices are managed through it. Introduce the term Cisco IOS by name here, Internet Operating System, and mention iOS XE, iOS XR, and NXOS exist as siblings. Both PC and network operating systems let you run programs and view output, just through different doors, mouse and monitor versus keyboard and monitor. Point out you can upgrade a device's iOS version to get new features, same as updating a phone's OS. 3 ways into a device. Console, physical, out of band, works even with no network configured. SSH, secure, in-band, needs an active network. And Telnet, insecure, plain text, lab use only, never production. Mention the legacy aux port on routers too. This table is exam relevant, so read it slowly. These are the terminal emulation programs that actually connect you to a device. PuTTY, TerraTerm, Secure CRT. PuTTY is what we will use in labs. Free, lightweight, and the most common in this course. Good moment to confirm everyone has PuTTY installed before the next lab. iOS splits access into 2 modes for security. User exec, prompt ending in greater than, is view only. No config changes allowed. Privileged exec, prompt ending in hash, unlocks everything. Have students say the prompts out loud, switch greater than versus switch hash, since spotting the prompt is how they will navigate labs. To actually configure anything, you need global configuration mode, prompt ends in config hash. From there, line configuration mode handles console/SSH/telnet/AUX access, and interface configuration mode handles a specific port. These are submodes underneath global config, not separate paths. Walk this command chain live if you can. Enable takes you from user to privileged exec. Configure terminal drops you into global config, then further commands nest you deeper. Exit backs up 1 level. End or Ctrl+Z jumps straight back to privileged exec from anywhere. Students confuse exit and end constantly. Drill this. Every command follows command keyword argument syntax. Keywords are fixed, defined by the OS, like IP protocols. Arguments are supplied by the user, like an IP address in a ping command. Use the ping and show IP protocols examples on screen to point out which part is which. This syntax check table matters for reading Cisco documentation, not just this course. Boldface means type it exactly. Italics means you supply the value. Square brackets are optional. Braces are required. Braces with a pipe inside mean pick one. Point at each example command and have them classify the parts. 2 built-in help types. Context-sensitive help. Press to see what is available at any point, and command syntax check. iOS tells you what is wrong if a command fails. Have students actually try switch greater than? Live in packet tracer right now if time allows. This is the single most useful CLI habit to build early. Hotkeys and abbreviations speed up real CLI work. Tab completes a command. Ctrl+A jumps to line start. Ctrl+E to line end. Arrow keys recall command history. Mention that commands can be abbreviated to the shortest unique string, like conference for configure. This is what experienced admins actually type. Continuing hotkeys. The more prompt appears when output is longer than the screen. Enter shows 1 more line. Spacebar shows a full screen. Ctrl+Shift+6 is the all-purpose abort key for stuck pings, traceroutes, or DNS lookups, worth demonstrating live since students will need it in labs. First configuration command on any device. Give it a real hostname. Default switch is useless once you have more than 1 device. Walk the naming rules. Start with a letter, no spaces, end in a letter or digit. Demonstrate hostname SWFloor1, and note it takes effect immediately in the prompt. Weak passwords are still the #1 security gap in real networks. Emphasize the note here. Labs in this course use simple passwords like Cisco or class, purely for convenience. Flag clearly that these should never touch a production device. Every access method needs its own strong, unique password. Console access needs its own password, even though it is a physical connection. Walk the command sequence line console 0, enters that specific line's config mode. Password sets it. Login enables the prompt. Explain that 0 just identifies the first and usually only console line on the device. Privileged exec is the most important thing to lock down, since it grants full control. Enable secret sets that password. VTY lines handle remote Telnet/SSH access. Most switches support 16 of them, numbered 0 to 15. Solene VT015 configures all of them at once with a single password. By default, most passwords sit in plain text inside the config files. Anyone with file access can read them. Service password encryption fixes that with one command. Be clear, this is weak. Legacy encryption for the stored file only. It does nothing to protect passwords sent over the wire. A banner message is the legal backstop to your passwords. It puts unauthorized users on notice before they get in, which matters in some jurisdictions for prosecution. Banner _d sets the message. The delimiting character, here hash, just has to not appear inside the message text itself. 2 configuration files to know cold. Startup config lives in NVRAM, survives a power cycle, and is what loads on boot. Running config lives in RAM, reflects live changes, and is lost on reboot. Copy running config startup config is the single most important command in this section. Say it twice. If a live change breaks something, you have 2 ways back. Undo the specific change, or reload the whole device, only if unsaved changes are the actual problem. Erase startup config wipes NVRAM entirely, and forces factory defaults on the next reload stress. This is a last resort, since it takes the device offline. Configs can also be saved outside the device entirely, as a plain text file via terminal logging. Walk the 4-step flow on screen. Open terminal software, enable logging to a named file, run show running config, then reuse that saved text later by pasting it back in as a working copy. End devices need 3 things to communicate: an IP address, a subnet mask, and a default gateway. List the device types that need an IP beyond just computers: printers, VoIP phones, security cameras, even barcode scanners. Note: IP in this course covers both IPv4 and IPv6, with IPv6 gradually taking over. Communication ultimately depends on physical interfaces and the cabling connecting them. 3 media types: copper, twisted pair, most common for LANs, fiber optic, light pulses, high bandwidth, long distance, wireless, no cable, electromagnetic waves. Each has a matching interface spec on the device. Manual IP configuration on a Windows end device. Walk the 4-click path. Control panel, adapter properties, IPv4 properties, then enter the address, subnet mask, and gateway by hand. Compare this to a phone number analogy. You need the address to actually reach another device. DHCP automates all of that. Almost every network relies on it rather than manual entry, since manual entry does not scale and risks duplicate addresses. On Windows, obtain an IP address automatically, does the work. Mention IPv6's equivalents here too. DHCPv6 and SLAAC handle dynamic addressing on that side. To manage a switch remotely, it needs its own IP address, configured on the VLAN1 SVI, a virtual interface, not a physical port. Walk the command block. Interface VLAN1, IP address, no shutdown to activate it. Then IP default gateway at global config level, same idea as a PC's gateway. 3 verification commands to close the loop. Show IP interface brief confirms switch interface status and addressing. IP config checks a Windows host's own IP settings, and ping tests actual reachability to another device or the internet. This is the everyday troubleshooting starting point. Have students run all 3 in Packet Tracer. Recap the module by walking each bullet, not reading it verbatim. OS access via CLI or GUI. iOS's 4 command modes: keyword/argument syntax with hotkeys, securing every access method, startup config versus running config, IP addressing manual or DHCP, and verifying with show IP interface brief, IP config, and ping.